Okay, so today we'll be looking at the Find All Anagrams in a String problem on Leetcode. This is essentially the same thing as the other question that we did, which was the find permutation or whatever question that was called. It's essentially the same thing, it's just now we want to tell them every single window in which we find the P string, I guess, in this case. So for this, same thing, we're going to have, for this case, we'll initialize variables first. Only because since the result is like a list, I mean, I guess I could just return, we'll do the edge cases. So if, same thing, right, if the length of S is, I mean, actually, it doesn't matter if the edge cases, because they're all like the same, right? If length of P, honestly, that one's kinda undefined, so we're just going to go is none or P is none. We're going to return just an empty array. So the one that I was talking about is if length of P is equal to 0. Because if you remember in the other video, I said technically you could find the permutation, right? But technically here, you could return 1 for every number of the length of the string until you hit length of the string minus 1. But it's kind of undefined. That's one that you would actually talk to your interviewer about. So in this case, we're not even going to handle it. And so now we're going to initialize our variables. So basically, we're going to do essentially the same thing, right? We're going to do a P count. Actually, you can do it the same way as the other video. However, this one made the most sense to me, and you could save a little bit more space with this, because this would be O of n plus m space. However, for the other solution, if we use the find permutation solution, you could probably get an O of n space solution, but this is just easier for me. So P count, dictionary to store current count for string P. I can make another video which does the other solution, but this is just the solution that came more naturally to me, or at least this is the solution that I did when I first did this question. So I think it just makes more sense for me to code it this way. Obviously, you can make slight you can make it slightly better, but I think it's just much easier if you can figure it out in the other way. Because the other way, like, you can save the space of P, which typically has to be shorter than S, because if it's just longer, then it'll never be true. But yeah, so this is just the more natural solution for me, and we're gonna have left. In this one, I'll just do both at the same time. So left and right bounds of our window, and then we're gonna have our result, which is equal to this result array. I think they're actually called lists in Python, but here we're going to do if P is longer than S, we can just exit, right? And so we can just do if length of p is longer than s, we just return the result. And then so we're going to build the dictionaries. Right. So what we're going to do here is slightly complicated, but while not end, right, is less than the length of p, we're going to do p count of p right is equal to p count dot get p right 0 plus 1. I'm going to do the same thing for s. S right is equal to s count dot get s right comma 0 plus 1. And this is because we're just going to go through the length of p as well as the first 3 letters of s, and then we're going to be adding the character and their count into each respective dictionary. And so the reason why I'm building both at the same time is because since I'm already counting the first 3, I might as well just do the 3, or counting the first 3 in this case, might as well do the first 3 here as well, right? And so if p count is equal to s count, then we just res.append. We can just do left actually. I think last time I did append 0, but that just happens to be the base case. But we can also just append left here still. And so this is, since dictionaries in Python, when you do double equal, it does like deep equality. I think that's what it's called. And basically it just means we look at the internals, and as long as the internals match up, then we match up. If you do something like p count is s count, then it actually accounts for like, think where it's stored in memory. And if it's not stored in the same memory, which it isn't because we stored it in different variables, we didn't do like p count equals this and the s count equals p count. So since it's stored in different places in memory, it will not, p count is not s count, right? Like they don't reside in the same places in memory. So double equals does deep equality on dictionaries in Python. Other languages may vary. And so now we're going to go through the rest of the string, rest of s, and try to find a window in which we can find an anagram. And so while end is less than the length of s, so now we're going through the rest of s, right? While it's there, we're going to s count of s left minus equals 1, because we know guaranteed that it's already in the dictionary. We don't need to check whether or not it's in there because we're putting everything in there, right? So we're going to guarantee that, you know, hey, it gets there. And then so here now we do if s count of s left is equal to 0, then we're going to do s count dot pop s left. So the reason why I need to do this is because if it doesn't exist in the right dictionary, then we need to pop it out, because it doesn't make sense for it to, not in the right dictionary, in the p dictionary, then we need to pop it out, because if it never exists in p, even if it has a value of 0, then it would never equal each other. So we need to make sure we pop it out. And then so we do s count of s right now, right? We need to do is equal to s count dot get s right 0 plus 1. Oh shoot, plus 1. Because since we're going into uncharted territory, we don't know whether or not we have put that certain character in yet, so we still need to do dot get and default to 0 if it's not there. And so now we need to do start plus equals 1, and not start. That's what I used before. Left plus equals 1 and right plus equals 1, because we need to increment our window by 1 over, and if s count is equal to p count, then res.append left. And now we want to return res, because we're done. After we shimmy it all over, we're good. Oh no, this is not end. This is right. And so is this. These are all right, because I used different variable name this time. So it is good. There we go. It's the same code, different variable name though, but it's a bit slower. Happens though, but yeah, that's it.